Hi, Stuart here. At long last, version 1 of a working enterprise queue in Postgres. So you can go check it out on the GitHub. You can check out the READMEs, which are good documentation. You can see how I built the Postgres container that I use for doing development and testing in my previous video. And I'm using the excellent PG cron plugin for Postgres developed by the Citrus Data folks. So thank you to them. They do excellent work. If you have any problems or comments or suggestions, I welcome pull requests. I welcome issues. Please go to my GitHub, file an issue, file a pull request. So I love enterprise queuing because in my professional life, I spend a lot of time building things on clouds that require durability and predictable behavior. And to do that, I find that enterprise queues are good intermediaries in producer-consumer pattern. Queuing allows you to have producers and consumers at different scales that come and go on different timelines, so the producers can be offline and the consumers can be perfectly happy and vice versa. They can have all sorts of charming attributes. I have lots of YouTube videos on enterprise architecture. I talk about enterprise queuing effusively and at great detail. But here's some high-level bullets about what I think is important in an enterprise queue. And so it needs to enforce leasing. In other words, if you dequeue a message off the queue, it enforces the rule that you have to proactively call it back and say, I did something with this message, or the message pops back onto the queue. That's what leasing means. Messages don't live forever. So when a message is enqueued onto the queue by a producer, it needs to be serviced inside its time to live, or it goes into dead letters. It needs to encourage the unit of work pattern with explicit message outcomes. Again, when you dequeue a message, if you're a consumer, you need to explicitly say, I processed this message successfully, or I didn't, or the message is terrible, or whatever. We'll talk about that. It needs to manage its own table hygiene and keep them clean. It needs to drag an audit trail, so every operation against the queue needs to be audited. It needs to have a history to retain the successfully processed messages. It needs to have a dead letter to hold bad messages. It needs retention policies. It needs lots of other fun things that I go into in the documentation that are in the GitHub. And you can read all about the documentation. The best documentation is the implementation, which you'll find in the PowerShell scripts and the SQL scripts. But I've done my best to explain my reasoning and how things work in considerable detail, because one of the things that I found very frustrating about working with Postgres is how hard it is to find the next level or the next level behind the next level of detail about actually doing things in Postgres. And it took me forever to implement this. And I'm not even 1,000% sure that it's absolutely correct, because it was very hard to find the philosophy behind when to do this versus when to do that. So I narrate my decisions, but also the consequences of changing configuration. I talk a lot about the message lifecycle. I try to be really clear on how to administer it, how to configure it, and how, as a developer, to use it with actual code examples. And we're going to demonstrate that in the video. That's the thing I want to focus on, is we make an enterprise queue because we have an architecture that needs one, and I want to show you how to use one. So again, as you read the documentation, if you have questions, if you have problems, please do reach out. At the heart of enterprise queuing is this notion that queue messages themselves have a message state. When they're created, their finite state machine state is queued. When you dequeue them, they become leased. When you say the message was successfully processed, which is called an ACK, They go to history and they have a status of history in the history table. If you recover them from history, they're queued again. If while they're leased, the lease expires and they get rescheduled, they become rescheduled and they're available to be leased again. If you explicitly say, I can't process this message, there's something wrong with the unit of work itself. Usually it's because there's some dependency. You go to call the XYZ service and it's temporarily down. And so you just knack the message. You say, look, this could be processed in the future. I can't do it now. And so you knack the message, which causes it to be rescheduled. And there's two levels of knacking. One is just the knack, which is, reprocess this message as soon as you can. And the other is a hard reschedule, which boots the message into the future. And we'll talk about when you want to use one versus the other in a minute. But the other thing that can happen is you can go to process the message and it's malformed. Or you go to call the XYZ service as part of your unit of work and it goes, hey, I've already done that unit of work, so you don't need to do it again. So you've got a choice at that point, semantically, depending on what your unit of work is. Believe it or not, the right thing to do is to kick it to dead letters, to say, this message is actually in error because it's already been done. But you could technically, in that use case, kick it to history. It's a preference as long as all the developers on your project give the same understanding of what the rules are for kicking things to history versus dead letter. It's fine. But if some people do it one way and some people do it the other way, it's totally not fine. The unambiguous use case is the message is malformed or unprocessable. Call the XYZ service with the IDs that are in the message payload and it goes, man, I've never heard of those. Or they're just horrible, right? They fail some validation. They are just garbage and they should go to dead letter. Now, in a healthy system, the dead letter queue or the dead letter table should be empty, right? If you find on inspection, and let me just say right now, as a matter of operation, if you own an enterprise queue, something or someone should be watching it. And if there's more than some threshold of dead letters in the dead letter table, that should spark some operational interest, right? That should be investigated. That is a bad thing, TM. And then the other thing you have to think about is, what your data retention policy is for your organization for the messages that are in history or dead letter. Obviously, we hope that you're backing all these things up. But in addition to that, what is your data retention policy for these records to be in the so-called hot layer of storage? For performance reasons, we want history, dead letter, and the queue table to have as few records as possible. But you have to balance that against what your retention policy. The other thing is that these labels are in a lookup table in the schema, and we'll show you that in a minute. But everywhere that they're used by their integer ID numbers, so that if you wanted to localize these states to whatever is appropriate for where you're programming, Japanese or Hungarian or whatever, you can absolutely do that. And it won't affect the functionality at all. So now we have to talk about the unit of work pattern, which is a pretty simple idea, right? A unit of work pattern starts when your worker process, your consumer, calls DQ and gets a message. At that point, a timer effectively is running over in the queue. There's no timer as it happens. It's just a timestamp on the message itself in the queue table. And you have that number of seconds to do something useful with the message. And then you are obligated to explicitly call back ACK, NACK, reject, or reschedule. 1, 2, 3, or 4, right? Which causes the message to stay in the message queue, but get an updated, next available time, or be booted into message history as being successfully processed, or be booted into dead letter as being unprocessable. If you do nothing, if your unit of work errors out, or your process that hosts your unit of work crashes, the system will recover your message because it will see that it never got rock and rolled. It's leased. It's in status 2 as it happens. And there's a lease expiration and a leased by in the columns for that message. And the next time somebody calls DQ and that message is available, someone else will get it and their lease clock will start and they will own the process and so on. Additionally, there's a cron job. Remember our friends at Citrus Data? Well, we're going to use their cron job, and every 7 minutes, and you can change this, but it turns out 7 minutes is the sweet spot, up to about 10 million concurrent messages. And it will do forcible unlocking of things that are stuck, because every once in a while, the dequeuing mechanism left to itself will occasionally create an orphan. Now, there's an interesting side effect to real enterprise queues, and that is they don't guarantee in-order delivery. But generally speaking, healthy systems with consumers that are not mental will generally process messages in order, but it's not guaranteed. And in fact, when systems like this become unhealthy, you can't guarantee in order. And that's okay. The unhealthy obsession with in-order delivery is what caused queued systems to have very bad throughput. And when you dig into it, there's almost no case where a healthy system needs in-order delivery. For example, if you have an accounting system, and you would think, well, I need to process this transaction ahead of that transaction against General Ledger. But it turns out real-world systems that run General Ledger, when they reify the transaction ledger and they play them against the books, so to speak, they order them by the timestamp that they were applied. And then they apply a certain sort of logic that orders the debits and credits and weights by chart of accounts so that the output is rational, right? They didn't need in-order delivery in order to do that. They were able to resolve the trial balance without having to resort to in-order delivery. So this system makes no effort other than the observation that if you look in the audit table and you look at the order that messages were queued into the system by the producer, and you look at the general order in which they're processed, if the whole system is healthy, they'll generally be processed in the order that they were queued. So you've got two options, right? If you want to play with this. One is if you have your own Postgres instance, right? You can run the makequeue utility and point it at your connection string, or you can fire up my custom Postgres container in your favorite Docker host. And if you don't want to use Docker, you can use one of the other container hosting engines. It doesn't really matter. But you do want to use my Docker file and create the image, because that image and then the script that I use to customize that image will customize the base Postgres 16 and add the plugins that the PEQ system or Postgres Enterprise Queue system depends on. And then it's simply a very easy thing. You pick a schema name. Each queue lives in its own schema, and I'll explain more of that during the demo, and supply a connection string, and then you run make queue and you give it the connection string and the schema you want it to make it in, and it will knock you out an empty queue system with all the bells and whistles and cron jobs and everything all configured, all ready for you to use and enjoy. So we're going to show you this code running live, but I want to show you just how easy this code is, relatively speaking, for developers to use. Because one of the things that I've learned over almost 40 years of building APIs for real humans is you want them to be dead simple to understand. And for producers, your only real obligation is to call the enqueue method and pass it a valid piece of JSON to store. You don't need to give it a message ID. You don't need to tell it who you are. You don't need to give it a bunch of other things like policy things, like whatever. There are lots of optional parameters that you can supply if you have use cases. For example, you can have messages that are enqueued that aren't available for an hour or whatever if you have special cases. But this is the 80% use case. Here's a chunk of JSON that I'd like the consumer to process. Really easy. By the way, throughout the slides, you'll see schema in braces or test01, which is my test namespace, used interchangeably. Same thing. The scripts, the base scripts all have schema and braces as a replaceable token, and it's replaced by your namespace when you run the script. If you're a consumer, you got to do a few more steps. 4 of them, in fact, the 4 we talked about. You dequeue a message by doing a select statement, and you pull the values from the dequeue method, which is the message ID of the message you're dequeuing, which you'll need later. The expiration, which is purely advisory, that just says, by the way, you get this message until this absolute timestamp. And of course, the actual JSON message itself into these variables, right? If you're programming in C# or Python or JavaScript or whatever your library wrapper is around PG-SQL will transport these 3 columns into whatever it puts those things in, but they're pretty accessible. I just left this example in pure PG-SQL for simplicity. So then you do some sort of unit of work. And you have to set what the outcome is. And generally, if things went well, the outcome is 1, act. And if for some reason you couldn't finish processing, the outcome is NAC, unless the reason you couldn't do something is that some dependent service is down, and NAC will kick your message to be processed into the future by seconds. If you want to kick it into the future by more than that because you think, well, it may take a while for the dependent service to come back up, and you don't want, your consumer to just spend all its time grinding its gears, or worse, hammering the dependent service, like, are you up yet? Are you up yet? Are you up yet? Then you can call reschedule. And you can say, look, give it 10 minutes, give it 15 minutes, give it whatever. And reschedule does everything NAC does, but it will allow you to boot it into the future. Also, reschedule extends the expiration time of the message. The rationale being that if I had to do something that causes the message to be booted deeply into the future, and by deeply, you have to understand, seconds is a long time in Computerville, right? Minutes is an eternity in Computerville. So if I call reschedule, I probably should extend the expiration time of the message by the same amount. So reschedule does everything NAC does, but it also extends the expiration time as well. NAC is in seconds, reschedules in minutes. And again, if the message is terrible for some reason, you call reject. And I strongly urge you to make the reason why explanation a pretty good one. And client ID is the unique ID of your client. When you every time a process spins up that will do the unit of work, it should have a unique ID. If you don't have a nice way of having unique ID, use the OG unique ID maker. Just if your programming language has GUIDs, do a new GUID and toString it. And you've got a unique client ID, because you want to avoid the scenario where 2 processes are executing units of work with the same client ID. This would be a bad thing, and it runs the risk that the 2 different processes could process the same message, or one process could complete the state of a message another process is processing, and you get really peculiar results, and you don't want that. So do yourself a favor and make sure client ID is always unique. And likewise, you want a good audit trail, so know your reasons why. Everywhere you see a reason why in an API, make sure that you have a pretty loving and loquacious reason why. The use of error codes and reason codes and things like that as part of the reason why, and having the reason why be well formatted is a good thing. We in no way enforce it. It's up to you, but I strongly suggest it. And then if any of these methods throw, right, they say, hey, no, this failed. You need to take this into your own hands and undo your unit of work. And the most common reason for these things to have failed is that you took too long to process it, and these 4 methods decided you didn't own the message anymore and said, you can't update a message you don't own, and just said no. But it'll reject it if you have a bad message ID, like the message has disappeared, or, the client ID is no good, or whatever. So, be aware that in the semi-rare case that one of these confirmation methods throws, you may need to do some compensation and potentially undo your units of work. Or you could be clever and just make sure that all your units of work are reentrant. What do I mean? I mean, for the same message, you could run the unit of work an infinite number of times without negatively impacting the result. Okay, we're going to run make queue using the defaults, which are the Docker container that I've spun up in the previous video. I have it running right now. It's empty. It's got a Postgres database with the default standard Postgres-y things in, and into it we're going to make a new schema called test01, and we're going to put all of the Postgres enterprise queue items into it. Here we go. So here's pgadmin, and you can see I have attached it to my Docker Postgres database. Here's the test01 schema we just made. And in it, we have the various procedures and functions and tables, including the main message queuing table, the history table, the audit table, the dead letter table, our message state and message configuration table. You can read all about those in the documentation that's up in the GitHub. And we're going to use the post-deployment test, and we're going to create some data and messages and enqueue them into the queue. And then we're going to do a bunch of units of work on them with random outcomes 1 through 4. So knack, ack, reject, and reschedule. And we can go see the outcomes of these by using the handy script that's in the utilities called find messages. We'll just go into here and replace start of a message ID. And you can see that this message was enqueued, dequeued, and it was successfully processed. Let's find one with a different use case. Here's a message that was rejected. So let's go grab the start of that message ID, and we'll see what that looks like. And you can see that it was sent to dead letter with the comment of bad format. You'd probably want to say more than that. Again, you want an effusive reason why. Let's find one that was rescheduled, which again is a long form of a knack. And you can see that it was rescheduled and it was delayed by a certain number of seconds. So very easy to use system that does a lot of enterprise best practice things. Lots of handy procedures to recover messages from dead letter or replay messages from history. Cron jobs that run that do a lot of tidying up. You can read all about that. Again, if you have useful suggestions or questions or anything, if you found this video helpful, please leave a comment in the videos. If you have suggestions or comments or want to do a pull request, please hit me up on the GitHub. Thank you for your kind attention.